All right, so this is a neat little project I putting together. Um, Basically, using I have one image here that is 256 pixels on an edge. I'm currently scaling it. So the image is 256 by 256, and this window is 512 by 768. So we've got pixels scaled to be about, well, it's as exact as I can get it. It's 2 pixels by 3 pixels. My thinking with this is a couple different things. Raymarching is expensive per ray. If I can really bring that resolution down, maybe I can do way more stuff. We'll take a look at it. This is about as deep as I've gotten into Raymarching. Right now, I've got controls to move the light, and so we can get some, some lighting action here. So basically, what's happening here is that image is being used for it's being used to raycast this image initially. This plane and sphere and the light, and then once it's been raycast, not raycast, it's raymarching. I've generally been working with raycasting, something very similar to raycasting. This is raymarching. This is sphere tracing. Shadows are very easy, and I don't have to hold anything like a light buffer like what I had been doing for Veraldo. This is a very different system that we're working with, but it's I think it's got a lot of potential. The dithering is done. It's what's called an ordered dithering matrix. Basically, I'm restricting the palette. Let me just real quick resize this. Okay, so basically what's happening here is I'm using this, not using the 8x8, and I'll explain why that is. So basically, well, here, let me do this in order. Here I've got, I just set up the uniform for the light position. This is the compute shader that says, what does the raymarching and stores it in this image 2D current. It's an unsigned image with 8 bits for each of the 4 channels. So this is, I just followed a very basic tutorial on raymarching. There's really only a couple of very small changes from the guy's code. I'll put a link in the description of the video here. Well, is it easy to pull it up really quick? This is the video. It's by this fellow, The Art of Code. and he's got some other good videos on operations to do with signed distance fields and other simple shapes. So that's something I'm going to be digging into in the next few days. But I'm very happy to have this much done. And as you can see, it's got just a very simple diffuse lighting model. You know, some other interesting extensions might be add more lights, figure out soft shadows. There's a lot of interesting directions to go with this. I haven't really gotten into it yet. Basically, you get your pixel offsets, you map it to the range -1 to 1. You initialize your color at black. You pick your origin. Here the camera position is 0, 1, 0, so that's 1 unit up on the y-axis at the origin. And the sphere position is hard-coded right now. And this is kind of an interesting little thing that I saw this guy do. He's keeping the sphere as a vec4 where the 4th coordinate is the radius. So it's being used. Then another cool little trick I saw done was this one here. You got some epsilon and 0, and you're using it to generate these vec3s. I don't know, it's a neat little compact way to do that. I don't claim to track 100% what's going on here. It's basically, so you've got your point and then some epsilon in each x, y, and z direction, and so that's going to give you like some positive or negative value for x, right? And this is kind of like a mask, the way this is being used. This is for y, and then this is for z, right? It's because the x is 0.01. XYY means that it's going to be 0.0100. This one's going to be 0.010. This one's 0.01. Then you normalize that, pass it back. You got the normal. Pretty wild. I'm really liking signed distance fields. I've been putting off experimenting with these for a while until I understand. Until I understood compute shaders a little better. So, right, we've got our origin. It's kind of a neat little thing to generate a camera. The rays are normalized. You've got your x and y pixel offsets, and it's stepped forward 1 unit, right? I thought this was clever because basically it's a point in 3 space that's just you know, I mean, you're basically automatically generating a frustum here. But, yeah, and so you calculate your distance with this Raymarch function. This was something I was messing with. I can actually do that. So this is kind of a cool little thing. Visualizing the number of Raymarch steps. I should actually bump up the number to something where you can have fully transparent rays. So right now, I'm just capping it at 100. I don't know if this is going to change anything. We'll check it out. So, that up. Okay, yeah. So we are seeing some stuff that goes that way. I really like doing this this way with the a compute shader computing the image. And the reason for that being that this is completely independent of this resolution. The actual display is done with with two triangles, so the screen is split across the diagonal, and then for every fragment it references that current image in the texture unit 0, and it gives you this pixel. So here, this is I've seen this used for different things, but here it's basically just saying how many steps did this this ray take, and then set the color based on no. So this is I'm playing with a clear color, and I have an image that's partially transparent. So basically, the more steps there are, the more transparent that particular pixel is going to be. So that's all cool. Getting into the dithering, this is actually a neat little operation I found. It's very, very simple. I had seen it done with a much more complex scheme for HSV palettes, which I quite frankly don't see a huge amount of value in since I figured this out. I'll have to see once I'm dealing with more colors if this is really the way I want to handle it. But right now I'm thinking that this is good for my application here. Basically, I grabbed the Raymarch result here. I initialize an unsigned vector. Now, this is to grab the low bits. This is doing a binary AND with 0xf. It's treated as an unsigned number. So element-wise, we're doing binary AND. So x to x, y to y, z to z. And storing that back in this L value. Then to grab the high bits, I'm basically bit shifting so that it goes off the right hand side, and then bit shifting back to just fill that with zeros. Effectively, I'm just keeping the top 4 bits because each of those is it's an 8-bit 8 bits per channel. All right, so now this is the meat of it. This is the dithering matrix. This is the ordered dithering matrix. This fellow's code was quite helpful. The main thing that I got out of it was this matrix. Basically, when I want this index value, I just say, all right, give me this value, right? And what it does is it looks at the mod of GL invocation ID on the X and the Y, gives you a value out of this const array. Now, what that means is I have this sort of mask that's being used, and I'm comparing it against the low bits, right? So you look at this, basically I have 4 low bits that I'm considering. So 4 bits, you go from 0 to 16. Well, I'm just doing a simple comparison here against the low bits between the value from the matrix and the low bits. And based on that, I'm either assigning the original color value, or no, sorry, I'm assigning just the standard, just the bit shifted high bits, or right, I am giving it that +1, and the reason that I can do that is because I've bumped off the low bits, I've zeroed them out, so I know that I have space to make this addition. In that value, right? So if it's 1 that's currently being held, I'm going to need to think about that more. Yeah, I don't want to say anything definitive about that because I'm not actually 100% sure how that's working, or if that would roll over or do something that I don't want. I'm going to think more about that anyway. Then the resulting color value is stored back in the image at the appropriate position. The other one I'm just calling blit because that's the canonical term for what this operation is, and right. So the vertex shader is just it's just the positions, and then this one, this is. We'll just go ahead and do this real quick. Thought this might be kind of cool to add delineations here, and it may or may not be, but yeah, maybe. The dithering pattern seems looks more complex here. I guess this is kind of more realistic scan lines, maybe. I don't know. This is a little effect I've played with before. I don't know how useful it is. I think it looks kind of neat, but really only in certain applications. Oh, that's treble. Yeah, because that's just using simple discard logic here. That doesn't jive super well with doing that transparency thing. Yeah, I like it this way. This. I have to think about what's going on there. But yeah, in any event, this is working, which it's kind of big stuff for me because I'd never gotten into Raymarching here before. This is my first foray into it, and I feel like I have something that looks pretty cool. So, yeah.